Okay, I'm going to try to make a quick video here covering a little project that I've been working on using a BeagleBone Green and a simple breadboard cape. You can see here, I'm pointing to it, that's on top of the BeagleBone Green. So the BeagleBone Green is actually mostly obstructed by the cape board. This is a nice board made by Adafruit, which you can easily order, and makes putting together a quick prototype pretty easy. And the main component on the board, it's an integrated circuit, an analog to digital converter IC. This analog to digital converter IC is connected via the GPIO system on the BeagleBone Green to the PRU, which is the programmable real-time unit, and this is a 32-bit processor, auxiliary processor. There are actually two of these auxiliary processors on the BeagleBones, and these are capable of very high-speed real-time operation. They are directly connected to the ARM processor, so these can perform tasks in real time while your ARM processor is operating a non-real-time operating system like GNU Linux, and this opens up some pretty amazing possibilities. So this is a fairly simple experiment. I've written some C code that loads into the PRUs via the remote processor framework, which is a fairly new and experimental Linux driver framework, which is coming with the latest distributions of the Debian Linux operating system on the BeagleBones. So let me get down to a quick demo here. Some other features I should point out. There is a USB codec connected via this cable to the USB port on the BeagleBone Green, and I'm going to be playing some audio through this USB codec via the ALSA system, which is the Advanced Linux Sound Architecture, which is also kind of a fundamental part of the Linux kernel and is included on the distributions for Debian, or can easily be installed if it doesn't come with your particular distribution of Debian. And then the codec is connected to powered speakers, analog speakers. So let's see what we can do here. I've got a terminal window open on a Linux box, and I am connected into the BeagleBone Green via the SSH protocol and a terminal window, and this is just not going to focus very well. So I have some development files. It's just not going to focus. But anyway, I've got my executable, and I am going to fire the executable, if I can do this with one hand, and we'll see what happens. Well, nothing. Why is that? Oh! It's because my audio source is not running. I'm also using the Digilent Analog Discovery 2. This is being used as a logic analyzer and also as an analog audio source, which is feeding into the analog to digital converter. And this is the GUI display, and you have to hit the run button before this thing will output any sort of audio. And as soon as I hit the run button, now we can hear the tone coming from the powered speakers. And if we go back to this display, This is a very nice, well-designed GUI, and I'm going to flip over to the Logic Analyzer and zoom in on this. And once again, it's not focusing too well, but anyway, what we're looking at here is a Logic Analyzer display straight from the GPIOs on the BeagleBone, which are connected to the PRUs in a very direct fashion. And so this is what's called a SPI bus. And so the top waveform is the chip enable. There's a clock on the second line down, and then the data, which you can see is changing versus time on the third line down. The fourth line down is actually a very simple code that is being sent in the direction of the analog to digital converter to set it up for single-ended and some other configuration of the ADC, and then the pulse at the bottom, which looks very similar, but it serves a completely different purpose. That is a clock pulse that is being generated by one of the two PRUs and is being fed to the PRU, which actually does the work of the SPI, and also is the origin of the character driver, which is how the data gets from the PRU to the user space in the Linux operating system. And then from the Linux operating system, there's a user space C program which reads the data from the character driver and then writes that data into the advanced Linux sound architecture. And let me do another quick demo here. I'll prove that this thing actually does work. I can change the frequency. I'll go for a higher frequency tone. And also I could change the amplitude. Let me drop the amplitude way down. Okay, oops, actually that was the offset. That was the wrong thing to do. Let me drop the amplitude. Now you can barely hear it. Go back up with that. Let's go up to a full volt. There is an offset. I think I'm probably overdriving a little bit. Actually, I've got a negative, so the ADC is probably not liking that. Let me see if I can offset. Okay, that's better. So now the trough of the sinusoidal waveform is at 0 volts. And that's it. It's working. I'm playing live data captured by the PRU and brought into Linux user space and then transported into audio USB via the advanced Linux sound architecture.